This is Math Minutes with Mr. White. Okay, in this video I want to take a look at rationalizing the denominator of fractions. That means getting rid of a radical or an imaginary number that you might have in that denominator of that fraction. Now, I'll talk a little bit later why we need to get rid of it. We're going to go through quite a few examples, so let's get right to it today. After you get through all these examples today, I think you're going to have a great understanding of how to rationalize the denominator of a fraction. See, here you see 3 over the square root of 2. Now we've got a square root in the denominator. That's an irrational number, which is a non-repeating decimal. Now back before computers, that was very difficult to divide an integer like 3 divided by a non-repeating decimal like the square root of 2. So that's why they came up, or how they came up with this nifty little trick to get rid of the radical under the denominator. What we're going to do, because if you were to type this in your calculator to get some decimal, right? 3 divided by radical 2. Now we're not allowed to change that decimal. So we're going to multiply by the number 1 because that doesn't change the decimal that we're looking at here. But we're not really going to multiply by the number 1. We're going to multiply by something over itself. And the trick here is to take that radical that you see in the denominator and multiply by it over itself. So radical 2 over radical 2. Now you multiply fractions straight across, remember. So when I do that in this case, I'm going to get 3 times the square root of 2 over the square root of 2 times square root of 2. One of the properties of radicals is that you would take 2 times 2 and get them under the same radical. The square root of 4, which is a perfect square. So we get 3 times the square root of 2 all over 2. And always take a look at these numbers in the front and just see if that's a fraction that can reduce. And it's not. This would be the rationalized form of 3 over radical 2. So if you're on a multiple choice test, for example, and you got 3 over radical 2 as your answer, you're going to need to look for 3 radical 2 over 2 because that's the answer that's going to be there. Okay, let's get to the second example here. Now we've got a radical on the top and the bottom. So really, there's no difference with how you deal with this. You look at the denominator and you work with that radical. So radical 3 here is the problem. We need to get rid of that radical from the denominator. So we're going to multiply by the number 1, but not really, right? We're going to multiply by radical 3 over itself. Now we multiply straight across, and on the top we get radical 6 over radical 9 in the bottom, which of course is 3. Now eventually you can kind of skip that step of writing radical 9. So the final answer here would be the square root of 6 over 3. And that would be your answer. Here we have 3 things going on. We've got the number 6 outside the radical 5 all over 3. Again, the radical 3, that irrational number in the denominator is the problem here that we need to deal with. So we're going to multiply by radical 3 over radical 3. We multiply straight across, we get 6 radical 15 all over, and then remember 3 times 3 is 9. The square root of 9 is 3. Remember earlier I said don't forget to look and see if you can reduce. Well, you guys know 6 over 3 is the same thing as 2 over 1, or just 2. So the final answer would be 2 times the square root of 15. You also need to examine this radical and make sure there aren't any pairs hiding in there that need to come out of the radical. And I'm going to have some examples here of that in a moment. But this is fully simplified. We can go ahead and put a box around it. That is our answer. In this example, our numbers are a little bit bigger, so we may have to simplify the radical here at the end. So just be aware of that. Let's multiply by radical 12 over radical 12. And that gives us radical 27 times 12. I'm not going to go to my calculator because I'm going to want to split that up here in a moment anyway. All over 12. Now what I mean by splitting it up is radical 27 is 3 times 3 times 3. Now the 12 that's under there has a different factorization. These are called prime factorization. 12 is 3 times 4. So we've got a 3 there, and then 4 is 2 times 2. So the number 12 is 3 times 2 times 2. All of that is over 12. Don't forget that. Now, in order to get out of the radical, you need to find pairs. So there's a pair, right? 3 times 3. There's another one, and then there's another one. So everyone has a friend and can make it out of the radical. So we've got 3 pair. So we ended up with 3 times 3 times 2 outside of the radical, which is 18 over 12. And then that fraction can reduce. So 6 times 3 is 18, and 6 times 2 is 12. The 6's cancel, and we're left with 3 halves. That would be your final answer in this one. So that crazy radical statement there at the beginning, radical 27 over radical 12, because we're dealing with square roots, we're able to look for pairs there at the end and get quite a bit out. In fact, everything, and then it's simplified right down to 1.5. Now you could try that in your calculator. Try typing the square root of 27, close the parenthesis, and divide by the square root of 12 and see what you get. Okay, let's get to another example. So this time I have a binomial, a two-term thing on the top. Now I know it's just all numbers, but I'm going to treat it like a binomial. We're going to have to do the distributive property on the top. Watch this. So we're going to multiply by radical 10 over radical 10. Now on the top, we're going to have to do that distributive property and make sure we multiply everything by radical 10. So I get 3 radical 10 plus radical 50 all over the square root of 100 would be 10. So I did get rid of that radical in the denominator. Now let's see what we can do with that numerator. Now 3 radical 10 I don't believe can be simplified at all. So 3 radical 10 is just going to stay the same. However, the number 50 has 25 in it. So it is radical 25, which is 5. Radical 25 times 2 is radical 50. Don't forget, all of that is over 10. So we end up with 3 radical 10 plus 5 radical 2 all over 10. And then before you call it a day here, these 3 numbers, you should always check and just see if maybe there's something that divides into all the numbers that are on the outside. It has to be all of them, though, all 3 things. And no, they can't all divide by anything. The other thing I want to comment is no, you cannot simplify this at all. These are not common radicals. They're not like terms. We've got a radical 10 and we've got a radical 2, and that cannot be simplified. So we do have our answer on our hands. There you go. All right, so we had to do the distributive property. All right, I told you I had quite a few examples, plenty of twists and turns along the way too. This time I put that binomial in the bottom. Now this involves something called the conjugate. I'll try to write nice and neatly for you. The conjugate. The conjugate is where you change the sign here to a minus. So 2 minus radical 7 is going to be useful. We're going to use the conjugate of the denominator. We're going to multiply by the conjugate over itself. Because remember, we have to multiply by the number 1 so that we don't change any numbers along the way. So 2 minus radical 7 all over itself. Now I'm going to get this other one out of the way. Now on the top, you just do the distributive property like we did on the last problem, and we get 14 minus 7 radical 7. However, on the bottom, folks, this becomes a FOIL question. First, outside, inside, last from your work with polynomials. The good news here is this is a sum and difference pattern, so there won't be a middle term. So really you just have to multiply the 2 times the 2. You see the sum and difference pattern there? We've got 2 plus radical 7 and 2 minus radical 7. It's a pattern. So then the O and the I will add up to 0. We also need to take those last terms and multiply them. And we get minus the square root of 49. The square root of 49 is 7. So let's keep simplifying. 14 minus 7, radical 7, all over negative 3. Now, is that our answer, or can we simplify more? That's a question I certainly ask my students, trying to trap them, frankly, into thinking that just maybe you could subtract 14 minus 7 and get 7. But friends, these are not like terms. This is a radical 7 term, and this is just the constant 14s. They are not like terms, so order of operations says no, you cannot subtract 14 minus 7 and turn that into 7 radical 7 all over negative 3. So the correct answer to my question was there's nothing more we can do with that. Okay, so there's another twist for you to watch out for from your teachers. In this example, we have those two-term expressions in the top and the bottom of this. Now, we're probably going to focus on getting rid of the radical in the denominator. And we're going to use, do you remember the term for that? The conjugate of the denominator. And we're going to multiply by the number 1, so something divided by itself, and it's going to be that conjugate. So 3 plus radical 2 is the conjugate of the denominator. It just so happens, it's just an accident, which is how this problem was set up, that the tops are the same now. Okay, we are focusing on the conjugate of the denominator. All right, now we have FOIL questions on the top and the bottom. So we're going to go ahead and FOIL this out. So first, outside, inside, last. So 3 times 3 gives you 9. And then the outside and the inside here are the same. They're both 3 radical 2 when you multiply them out. So you add those together, you get 6 radical 2. The last terms here would be radical 2 times radical 2. That's radical 4, which is a plain old plus 2. And then in the denominator, we have a sum and difference pattern here, and that's why we use the conjugate, by the way. So a sum and difference pattern, do you remember? No middle term. We don't have to FOIL it out. We just take 3 times 3, which is 9, and then take negative radical 2 times positive radical 2. That's negative radical 4, which is negative 2. Let's go ahead and simplify this because we have some like terms here. So 11 plus 6 radical 2 all over 7. Now let me ask you this like I'd ask my students. Can this be simplified or changed in any way, or is this our answer? And the answer is, this is our answer. It cannot be simplified because of order of operations. You cannot add 11 and 6 and get 17. A lot of students would try to do that. The other thing to look for is whether there's maybe a common factor between this, this, and this. Do any of those, like, are they all divisible by 2, for example? They're not. So this is a fraction that is fully simplified and there are no like terms that can combine. So that is the answer. All right, let's get to the next one. We're going to be talking now about having an imaginary number in the denominator. Now, those of you who are taking maybe Algebra 2 and beyond, you might be familiar with imaginary numbers. Imaginary numbers are non-real numbers where I represents the square root of -1. So it's the same thing as having a radical in the denominator. When you see that I, it's the same thing as having the square root of -1. It's called an imaginary number. Now, to get rid of that radical in the denominator, we multiply by it over itself, right? I over I. Now you might say, well, don't those i's cancel? Yeah, that's the point. We're multiplying by the number 1. We multiply straight across and we get 7i over I squared. Now, again, those of you who have worked with imaginary numbers quite a bit, you probably know this. When you square the square root of -1, you get -1. So the final answer here would be -7i. -7i, right? Because that minus sign would just be attached to that numerator. So you get -7i. So this time, again, I put an imaginary number in the denominator, but it's a binomial type. So what are we going to use? The conjugate. In fact, it's called the complex conjugate because it has an imaginary component and a real component, the -3 and the I. So it's called the complex conjugate. Sounds really fancy, doesn't it? So let's get to this. We're going to multiply by -3 minus I. Notice I didn't change the -3 to +3. It's only that middle sign. All over -3 minus I. So on the top, we get -6 minus 2i. And on the bottom, this is one of those FOIL questions, but because it's a sum and difference pattern, thankfully, we just have to multiply -3 times -3, that would be 9, and then minus I squared. Now, whenever you see I squared, you can replace it with -1 for reasons I talked about on the last slide here. So we're going to have -6 minus 2i all over 9 minus 1 is really 9 plus 1. So we have -6 minus 2i all over 10. And sometimes we go ahead and reduce this further. This would be -6/10 would be -3/5. minus 1/5 I. Often we write it in that, it's called a complex number, complex form, where you have the real and then the imaginary component. So there's that example. Again, rationalizing the denominator, when you have a radical down there, it happened to be an imaginary number. Wow, we went through a lot of examples today. Hopefully you've got it now. You can get rid of the radicals in the denominator by multiplying by the number 1, something over itself, and it's always going to be that expression over itself, whatever's in the denominator. Okay, if you found this video helpful, I sure hope you'll like this video, subscribe to the channel, and then leave your comments down below. I really enjoy hearing from you. All right, until next time. This has been another edition of Math Minutes with Mr. White.